Welcome to a slow, beginner-friendly lesson on error handling with network calls in Python, made for absolute beginners. Failure is part of the job. Today we face the most realistic part of working with web services, failure. Until now, every request we wrote assumed the server was reachable and happy. Real networks are not so kind. Connections drop. Servers return errors. Tokens expire. Requests time out. A script that crashes on the first failure is useless in production. Today you learn to write API calls that fail gracefully, checking status codes, raising on errors, catching exceptions, and retrying when it makes sense. Networks fail. Here is the truth about networks. They are unreliable by default. Servers crash and restart. Routers drop packets. DNS lookups fail. Servers get overloaded and respond slowly or not at all. A script that assumes every call succeeds will crash at the worst moment, in the middle of the night, during an important job, when no one is watching. Your code must anticipate failure and handle it. Today you learn the patterns. Plan for it. Every network call is a fragile thread between your script and a faraway server. Most of the time the thread holds. Sometimes it snaps. Sometimes the server never answers. Sometimes the answer is an error. The professional skill is not avoiding failure, it is writing code that survives it. Threads snap. Here is the naive call. One line fetches the URL. The next parses the body. If the server is reachable and returns valid JSON, this works. But if the server is down, requests.get raises an exception and your script crashes. If the server returns an error page in HTML, JSON parsing fails and your script crashes. Naive code is fine for learning. It is dangerous in real work. Naive works until it doesn't. The first layer of defense is the status code. Every response has one. 200 means success. 404 means not found. 500 means the server broke. Read response.status code and decide what to do. If it is 200, parse the body. Otherwise, log or report the failure. This single check prevents the most common crash, parsing a body that is not what you expect. Read the status. For finer control, branch on the status code. 200, parse the user. 404, the resource does not exist, tell the user. 401, your token is missing or expired, ask for authentication. Anything else, report an unexpected status. This pattern lets you respond differently to different failures. You decide what each status means for your script. Different codes, different actions. Memorize the status code families. 2 something means success, 200 OK, 201 created, 204 no content. 4 something means your request was wrong, 400 bad request, 401 unauthorized, 404 not found, 429 too many requests. 5 something means the server failed, 500 internal, 502 bad gateway, 503 unavailable. Always check the service docs for the codes it returns. Learn the families. If you do not want to write the if statement every time, requests gives you a shortcut, response.raise for status. This method does nothing when the status is a success. But for 400 and above, it raises an HTTP error exception. Wrap the call and try and accept to catch it. This is cleaner than checking status codes manually when you only care about success or failure. The clean shortcut. Walk through the whole flow. You try the call. If requests raises a connection or timeout exception, you catch it and report a network failure. If the call returns, you check the status. On 200, you process the body. On 400 or 500, you handle the error, log it, retry, or surface it. Every robust call follows this shape: try, catch network failures, check status, handle each case. One shape, every call. Here is the standard shape. Wrap the entire call in a try block. Call requests.get. Call raise for status. Parse the body. If anything fails, connection, timeout, HTTP error, the except block catches it as a request exception, the parent class of all requests exceptions. Print or log the error. The else block runs only on full success. This is the foundation of every robust call. Try, then handle. Know the exception family. Connection error fires when the network is unreachable, DNS failure, refused connection, broken pipe. Timeout fires when the server does not answer in time. HTTP error fires when raise for status sees an error status. Request exception is the parent of all of these, catching it catches every request-related failure. Choose the specific exception when you want to handle one case, choose the parent when you want to catch them all. Know the family. Here we catch a connection error specifically. The host API.example.invalid does not exist, so DNS lookup fails and requests raises connection error. We print a friendly message instead of crashing. In real code, you might fall back to a cached response, alert an operator, or queue the request for later. The key is, your script keeps running. Network down. Without a timeout, a slow server can freeze your script forever. Always pass the timeout argument, 5 seconds here. If the server does not respond in time, requests raises timeout. Catch it and decide, retry, give up, or try a different server. The timeout protects your script from hanging. Without it, a single slow service can stall your entire program. Always pass timeout. Always pass timeout. The timeout argument can be a single number, the total time, or a tuple of two numbers. The first is the connect timeout, how long to wait to establish the connection. The second is the read timeout, how long to wait between bytes of the response. 3 seconds to connect, 10 to read is a common choice. Tuning these matters when you call many services with different speeds. Tune connect and read. Error handling is the shield between your script and chaos. Networks will fail. Servers will misbehave. Tokens will expire. With try, except, status checks, and timeouts, your script absorbs the hit and keeps going. Without these, the first hiccup brings everything down. Stand through chaos. Chain multiple except blocks to handle each failure type differently. Connection error prints network down. Timeout prints server too slow. HTTP error prints the status message. Python walks the except blocks top to bottom and runs the first one that matches. This gives you precise control, different recovery actions for different failures. Read each block as, if this goes wrong, do this. Specific handling, a warning. Avoid a bare except clause. It catches everything, including keyboard interrupt, including programming bugs you actually want to see. A bare except hides problems instead of solving them. Always catch a specific exception class, or at worst, exception. Be honest with your code, catch what you intend to handle, let the rest crash loudly so you can fix it. Never bare except, a common pattern, a function that returns the data on success and none on failure. Try the call. On any request's exception, return none. The caller checks, if the result is none, something went wrong, otherwise, use the data. This keeps the failure handling in one place and the calling code clean. Returning none is simple. For richer code, return a custom result object that carries the error. None signals failure. Some failures are temporary. A network blip clears in a second. An overloaded server recovers. A 429 too many requests explicitly tells you to wait. In these cases, retrying makes sense. Wait a moment, try again. But never retry forever. A permanent failure in a loop hangs your script. Set a small maximum, 3 attempts is a good starting point, and stop. The next lesson dives deeper into retries. Today we use a simple loop. Some failures pass. Here is a basic retry loop. Try the call. On success, break out of the loop. On failure, print which attempt failed and sleep 2 seconds before trying again. After 3 attempts the loop ends, successful or not. In real code you would track whether the last attempt succeeded and decide what to do. We keep it simple here. The key idea, a bounded loop that gives the service another chance. Bounded retries. Combine everything into one helper. Fetch JSON takes a URL, optional parameters, a retry count, and a timeout. It tries the call up to retries times. On success it returns the parse JSON. On any request's exception it logs the attempt and sleeps. If every attempt fails it returns none. This single function packages the patterns you learned. You will write a version of this in almost every project that calls web services. One helper, every pattern. Robust code is calm code. It does not panic when the network drops. It does not freeze when the server is slow. It tries, it waits, it reports. The lighthouse does not stop the storm, it stands through it. That is what error handling gives your scripts. Calm code. When something fails, do not silently swallow it. Log the error so you can diagnose it later. Python's logging module is the standard tool. Logging.error writes the message with a timestamp to your log file or console. Silent except blocks hide problems. Your script looks healthy while everything is broken. Always record what went wrong, even when you recover gracefully. Never silent. Put it all together in a realistic function. GetUsers builds the call with parameters and a timeout. It raises for status to convert errors into exceptions. Each except block logs a specific failure. The function returns the user list on success, an empty list on failure, so callers can iterate without checking for none. This is the shape of professional API code: clear, defensive, and easy to maintain. This is professional code. In one breath, networks fail, so assume they will. Check the status code or call raise for status to convert errors into exceptions. Catch the specific requests exception you expect, connection error, timeout, HTTP error, or request exception to catch them all. Always pass a timeout so a slow server cannot freeze your script. These 4 habits turn fragile scripts into robust ones. 4 habits. What comes next? Having covered parameters, headers, and error handling, the next lessons go deeper into JSON, how to parse nested responses, how to build request bodies for post calls, and how to use real public APIs end-to-end. You now have the core skills to call a web service safely. The next phase sharpens your fluency with the data those services return. JSON depth is next. Self-check before moving on. Can you check the status code before parsing the body? Can you catch a timeout specifically? Can you write a small function that retries once on failure? Can you explain in one sentence why every call should pass a timeout? If any feels shaky, rewatch the matching part. Error handling is the difference between scripts that look finished and scripts that survive contact with the real world. Say each out loud. For practice, call bin.org/status/500. It always returns a 500 status. Wrap the call in try and accept, call raise for status, and watch the HTTP error fire. Then try the URL with status/404 to see a different error. This is a safe playground for failure, every problem you might encounter, on demand. Practice until catching errors feels automatic. Practice failure safely. Thanks for learning to handle network failures. Next we go deeper into JSON. Robust calls, done.